tomorrow originally, but it is switched on so that you may have some mismatch on schedule, but let me try. Also, you may have a question, then raise anytime while I'm talking. So it is about the ocean plant design, how to design an ocean plant. So usually the ocean plant is called offshore structures, in other words. And mainly commercial application is for oil and gas development. And there are other offshore installations such as a mobile harbor, floating nuclear power plant, and floating wind power system. Okay. So this is a typical deep water field layout. At the top, you see that there are drilling systems, subsea drilling system at the left. So they start to drill the seabed to find out oil or gas. And then after successful finding out the reservoir, then another system is coming to make a production of oil and gas. It looks similar, but the equipment on top is different. They are pumping out subsea oil and gas. And then this right-hand side system is also similar one, but a different type. We call this is a FPSO, floating production and storage and offload. So those two systems have a same function, but shape is different. Right? At the bottom, you can see from the left that there is a keys and also manifold and subsea processing. Subsea processing is usually the FPSO is processing the crude oil from the well, but nowadays more process is going down to the subsea bottom because it can be more economical. We delete water or sand or mud from the oil, then only oil can be goes into the above the water. So that can be a system, and each well has a Christmas tree. Here it shows a white colored one. So you can see that each Christmas tree there is a one hole, and each hole then there is a pipeline goes into the manifold to make a more big pipeline, and then goes into the surface. It is a typical line or layout. And supply chain of offshore oil and gas, oil, gas, LNG, FLNG has a little bit similar but different supply chains. So they start from well drilling and then goes to subsea systems and production storage and transportation, and then finally fly to customers in the land. Okay. At the beginning, we should have a drilling rig type or ship type drilling system. And then at the subsea, the deep water near the bottom, there is a wellhead and process, subsea processing and pumping, compression. And URF is umbilical. Umbilical is a line, pipeline, riser, and flow line. And production storage, there is a fixed platform or floating one. And sometimes it is pipeline and floating LNG system, and transportation oil for tanker, or sometimes we use pipeline or LNG carrier. And at the left side, there is other type. So there is a short name for this. Let me show you one video for this. FLNG.
An FLNG is a floating facility that liquefies natural gas directly above an offshore reservoir with periodic offloading of the LNG product to shuttle tankers. With a solid track record in the design and delivery of FPSOs, LNG and subsea, TechnipFMC proposes a full range of services from the early concept definition phase through to engineering and execution. As a world leader in subsea projects, TechnipFMC offers its expertise in the design, construction, and installation of all subsea facilities, including in deep water. The turret anchors the FLNG to the seabed and allows it to rotate according to wind, waves, and currents. From the composition of the feed gas, TechnipFMC develops the optimum process and designs all the topside modules to receive the gas on deck from the wellheads, pre-treat the raw natural gas to remove CO2, water, and mercury. NGL is also removed with co-production of LPG and condensate when the gas is rich. Finally, the gas is liquefied in cryogenic exchangers using powerful refrigeration systems. The FLNG is designed to store a large quantity of LNG plus condensate and LPG as required. The LNG is stored temporarily in highly insulated tanks at atmospheric pressure and around minus 160 degrees Celsius. The LNG is then exported through LNG carriers. The LNG carrier is loaded side by side with the FLNG using marine loading arms. Where side-by-side offloading is impossible due to the site mid-ocean conditions, or if the client prefers otherwise, TechnipFMC with high-load LNG proposed the high-load LNG parallel loading system. This system, developed from proven and qualified technologies, allows offloading operations under harsh environmental conditions into conventional LNG carriers, a real breakthrough technology. The condensate offtake is through a conventional offshore offloading system. The FLNG is fitted with living quarters to accommodate operations and maintenance staff. TechnipFMC, your reliable partner and undisputed leader in FLNG.
All right. Well, you may notice that this one is two things I want to explore on this video. One thing is, this is not real one. This is coming from computer graphics. So this is some kind of artificial, but you can see more clearly because of the computer graphics. Second thing is the name of the company. The Technip FMC is a merge of two companies previously. Technip is a French company for offshore engineering. And also FMC is coming from Norway. That is more famous on deep sea engineering at the sea bottom. So the two companies are merged to be more stronger engineering backgrounds. All right. And move on to next slide of offshore installation types. There is a jackup type for the drilling unit. Drilling is for the exploration at the beginning of finding out oil and gas. And second type is semi-submersible. This is a floating type. But jackup is not floating. Jackup is just foot, the long leg. The foot is on the ground of the subsea bottom. But submersible is a kind of a floating type. Drill ship is final shape, also floating, and looks like a ship. Okay, so let me show you another jackup type video. Drill ship, drill unit. This is how the jackup style offshore structure is installed at the beginning. So this one, the jackup style. Then go on to, and this is a submersible type. So it looks floating with many mooring lines. And this straight black one is the drilling pipe or riser. And drill ship is similar one, but looks like a more ship-like shape. But function is very similar. So, and shallow water field, they usually use a jackup style, so footing there and the pipelines transport. That is for the shallow water, but deep water you cannot do this jackup. So we need to have a floating. Okay, and this is a real picture of jackup style and the platform where many modules are located. So it's complicated, and also there is a drill tower for the drill bit and pipe. And this one is a famous one coming from the Norway. There is a concrete structure, very high structure. You see that it is compared with the Eiffel Tower in France to show that how big it is as offshore structure. And they are flooded and downloaded to the seabed. So it is a kind of a fixed structure or jacob tile structure, but it is made of concrete rather than steel strut. So, and this is a floating tile FPSO and LNG FPSO. We already see the video. And then this is a carrier. So this is FPSO. So when the cargo rooms are full of gas, then the carrier is coming to transportation, only for transport. The offloading is coming. And this is a regasification system because the liquefied LNG, liquefied natural gas, it should be kept in minus 160 degrees Celsius. So room temperature gives them energy to gasification. So they should be reversed to the liquid by using a regasification or the liquefaction system. Right. This is a picture of that equipment to make them to make liquid to change to gas or get gas to be changed transformed to liquid again. And the other offshore installations, see that mobile harbor, we already see that. This one is handling of 250 TEU container boxes as a small port, container port with storage and cranes for container handling from the ship. So right-hand side, this part is mobile harbor. Left-hand side is just a typical conventional container ship. And this is an idea coming from MIT for the nuclear power plant, floating tile. So they can use water, enough of water from the ocean for the cooling of nuclear system. And this one is a floating nuclear power plant idea coming from KAIST as a small unit. Very similar to MIT type, but different because inside is Korea designed the nuclear system. Anyway, this is another idea of floating nuclear power system. Inside is shown here. There is a modules. Different modules are combined together. And this is wind turbine system we already see another time, but it is moving from land-based system, land-fixed system to ocean bottom fixed system, and now we are moving for the floating type. And you see also that the size is increasing toward more and more bigger size of floating type. And there is advantage and disadvantage of land fixed system, ocean bottom fixed, and floating type. And the size is increasing from 1980 to 2010. The 30 years of development, size of 50 kilowatt or 15 meter diameter. Now it is a 10 megawatt or 180 meter diameter, big change. Also, this stove is home stove for 2 kilowatt consumption of electricity. So you may see that how many homes can be covered by each unit for a city. Okay. Oh, that's the end of the slide set. right? So question? No? Then we may see you again tomorrow, 1 o'clock as usual. And we have two discussions. One lecture and two discussions. All right, then close earlier. Bye now.
Thank
See you
you.
tomorrow.
Bye bye.